Problem E5B9 says power cords for lamps and the like are often made of number 18 copper wire, which has a diameter of 1.01 millimeters. What is the resistance of 50 feet of such wire? Okay, so if this is our wire, and we're given that the diameter is equal to 1.01 millimeters, and we're told that the length of the wire is equal to 50 feet. So we can we know that there are 3.28 feet. Let's see, feet in 1 meter. So if L is equal to 50 feet divided by 3.28 feet will give me the number of meters, and that's equal to 15.2 meters. So that's how long our wire is in meters. And we know, we're told in equation, let's see, E516, that delta phi of the wire, and that just means delta phi means if I have a wire that's this long, that the voltage difference from this end to this end, that's what that means, delta phi, the voltage difference between these two ends, and that's equal to I times L and then sigma times A on the bottom. And now I also know that delta phi is equal to I times R, so the potential difference is equal to the current times the resistance. So I know that my resistance is equal to this value. So R is equal to L over sigma C times A. Okay, so now if I want to plug in our numbers, we have 15.2 meters. Here, the conductivity of copper, we can find that in table, I think it's 15.1, and that is 5.9 times 10 to the 7th, and the units are 1 over ohms times meters, and then our area is going to be pi r squared, so that's going to be 1.01 times 10 to the minus 3 meters, and that's squared, and then we have to divide by 2. Okay, and so when we work that out, we find that the resistance is equal to 0.32, and here this should be meters. We find that this is equal to 0.32 ohms. And that makes sense because I have a meters here, and this meters would convert to the numerator, and I have meters squared here. So those meters would cancel, and my ohms would go from the denominator, and the denominator would translate to the numerator, so I'm left with ohms.